Good afternoon, class. Today, I'll discuss with you parallelograms and related quadrilaterals such as rhombuses, rectangles, and squares. I will start with their properties, that is, properties of a parallelogram, properties of a square, properties of a rectangle, and properties of a rhombus. These properties are notes that you need to go through. They are the first thing you go through. You study them, very simple and explicit. When you go through them, you will understand. These properties are properties we are going to apply in this video to solve the following problems. Example 1. Look at the diagram. In the diagram, ABCD and CDEF are parallelograms. This shape ABCD that I'm tracing is a parallelogram. Also, CDEF is also a parallelogram. Then you have ABEF to be a straight line. B to E is 2 cm. D to C is 3 cm. So we are to calculate from A to F. How will I apply those properties I said you have in those notes to solve this particular problem? Here is my diagram. Now, this is 2 cm. This is 3 cm. Now, since ABCD is a parallelogram, that means this length AB is the same thing as 3 cm here, which is DC, because the opposite sides of a parallelogram are equal. When you check the properties of a parallelogram, you will see the opposite sides of a parallelogram are equal. So these two sides facing themselves are equal in length. So AB is 3 cm. Similarly, EF will be 3 cm because CDEF is a parallelogram. The opposite sides are equal. So this is 3 cm. With that, I can now get my AF, which will be AB plus BE plus EF. That is 3 plus 2 plus 3, which will now give us 8 cm. And that is how you take care of question 1. Example 2. Look at the diagram. In the diagram, ABCD is a rhombus. ABCD is a rhombus. And APCQ is a square. Please make sure you read carefully. ABCD is a rhombus. APCQ is a square. Angle PAB, the A in between PA and BA. PAB, the angle is 21 degrees. Calculate the 4 angles of ABCD. That is the 4 angles of your rhombus. You have to calculate them. Now, how will you solve this? You look at your diagram. This angle here to this side. No, let's start this way, sorry. The whole angle here in this your square, let's consider the square first. When you look at your square, the angle here, which is angle PAQ. That is angle PAQ. This angle PAQ, which is this angle, is the same thing as this angle, which is angle P, and is the same as this angle too, which is PCQ also. And is the same as this angle here, which is Q. All these angles will be 90 degrees each. Why? When you go to your square, you will see there all the four angles are 90 degrees in the diagram. When you see a square, the angles inside the square, you see them, they are right angles, angle 90 in four places. So this angle here is 90, this one is 90, this one is 90, this one is 90. Now, having known that, similarly, when you look at your diagram, this angle here, which is angle DAQ, this angle here, which is angle DAQ, is 21 degrees, like this, through symmetry. That's the reason. By viewing it symmetrically, this angle is 21 degrees. Therefore, we can get angle A as a whole to be 21 degrees plus 90 degrees plus 21 degrees. That's what you have here, which will give you 132 degrees. Remember, ABCD is a rhombus. And when you go back to the properties of a rhombus, one of them is that the opposite angles are equal. Therefore, this angle A as a whole will be equal to angle C as a whole. Therefore, angle C will also be 132 degrees. Angle D will be equal to angle B. Call it X. Then from your knowledge of polygons that you just treated, when you add the four angles in a quadrilateral, it will give you 360 degrees. When you use your formula 4 minus 2, which is 2, times 180 degrees, it will give you 360 degrees. So angle A plus angle B plus angle C plus angle D will give us 360 degrees. Angle A is 132 degrees. We calculated it here. Angle B is what we call X. We don't know it. Angle C is 132 degrees. It's the same as angle A because the opposite angles of a rhombus are equal. Angle D is X because the opposite angles of a rhombus are equal. Is the same as angle B, which will be 360 degrees. Add the 132 and 132, you have 264 degrees. Add your X, you have 2x. Collect your like terms. 2x will be 360 degrees minus 264 degrees, which will give you 96 degrees. Thereafter, divide both sides by 2, and x will be 48 degrees. Therefore, our angle A is the same as angle C, which we said is 132 degrees. Angle B is the same as angle D, which we give as x, and x is 48 degrees. So this is how you get your angles. Now, coming to this diagram here, when you study this diagram here, in the diagram A, B, C, D, E, that's all the shape. It is such that ABCD is a parallelogram. ABCD is a parallelogram, and ABDE is a square. MD is 3 cm. AD is 8.5 cm. We are to calculate the perimeter of ABCDE. Perimeter of ABCDE is the length around the shape. We need AB, we need BC, we need CD, we need DE, and EA. Now, when you check the properties of a parallelogram, one of them is that the diagonals bisect each other. So diagonal AC we bisect diagonal BD. Therefore, this 3 cm will be equal to 3 cm here, which is BM. BM is 3 cm. Now, if BM is 3 cm, BD as a whole will be 3 plus 3, which is 6 cm. Then if BD is 3 cm, since ABDE is a square, AB will be 6 cm, AE will be 6 cm, ED will be 6 cm. Why? When you go to a square, all the four sides are equal. Now, BC will be 8.5 cm. Why? Because ABCD is a parallelogram and the opposite sides are equal. BC is opposite to AD in the parallelogram. Therefore, BC will be equal to AD. Similarly, DC will be equal to AB, opposite sides of parallelogram, and AB is 6 cm. Now with this, we've gotten all the sides. You add them together. You say your AB plus BC plus CD plus DE plus AE. AB 6 plus BC 8 plus CD 6 plus DE 6 plus EA 6. That's what you have here. And that will give you 32.5 cm.